He is the founder and president of Physicians Committee for Responsible Medicine, PCRM, which is known across the world, and also founder of the Barnard Medical Care Center, which models around making nutrition a routine part of medical care, making prevention as a strategy. He's an adjunct associate professor of medicine at the George Washington University School of Medicine, and he's got some wonderful awards: the Lifestyle Medicine Trailblazer Award 2016 from the American College of Lifestyle Medicine, ACLM, and the 6th Plantrician Project Luminary Award in 2019 from the Plantrician Project. Huge contributions that have happened. I would say that the line which is at the end summarizes a lot of things that have happened through him. His writings aim at empowering readers with life-changing information and knowledge, and it has led him to be on numerous research studies investigating the effect of diet on diabetes, on body weight, on chronic pain, hormonal balances. 90 scientific publications, authored key resolutions for the AMA policy for new focus on prevention and nutrition, authored more than 19 books on nutrition and health, which has created a revolution in thinking of contemporary modern medicine physicians. Prolific writer, wonderful speaker. Let us call Dr. Barnard on stage with fireworks right now.
Well, thank you very much. Thank you. It's very, very kind of you to allow me to be part of today's program. Thank you very much. I'm extremely grateful to you. And I also want to say that what you have accomplished is something that if we could have this made available to everyone on the planet, things would be so dramatically different. What you have done not only improves the lives of the participants themselves, but it also reaches out to their family members, to their community members, and it spreads waves throughout the countries where people are participating. But it does more than that, and that is that it shows what is possible. And that provides inspiration, not only to individuals in their day-to-day lives, but to physicians in practice and to governments who can now set policies with more confidence about what we can do to tackle these terrible scourges that we're dealing with of obesity, cardiovascular disease, and particularly diabetes. So thank you very much for allowing me to spend this time with you. May I share my screen and share some comments with you?
Yes, please. Go ahead.
If you don't mind, I would like to start by talking about the pandemic that we're dealing with right now, because as you'll see, it relates very strongly to nutrition and ultimately to diabetes. But when the COVID-19 pandemic emerged in China, very rapidly, it was clear that it was not a particularly democratic virus. In other words, it attacked different people very differently. For people who were normal weight, the likelihood of having severe disease, meaning you end up in intensive care or need to have a ventilator, or perhaps you may perish from the virus, it was 19% in normal weight people, 29% in overweight people, 39% in people who were obese, and surprisingly, although we often think of underweight people as being vulnerable, there was no one who was underweight who had serious disease at the beginning of the Chinese outbreak. And what that suggested is that there was something about carrying excess body fat that made this virus particularly deadly. And we believe that we know what that is. Fat cells might be thought of as just a bag of calories, but they're actually much more than that. They are factories that make all kinds of aspects of human metabolism. Among the things that a fat cell makes is the ACE2 receptor, angiotensin converting enzyme 2 receptor, which is expressed on the surface of the cell and is the point of attachment of the SARS-CoV-2 virus. In other words, one inhales the virus. It then it travels to the ACE2 receptor, and that's what acts as a welcome mat bringing it into the cells. But there's more than that. Lung cells actually have what are called lipofibroblasts. It's a sort of a modified fat cell that allows the lung to be somewhat elastic. As you know, when you breathe in, your lungs stretch. When you breathe out, they contract. But as the disease progresses, these cells are converted to myofibroblasts and ultimately cause lung fibrosis, meaning the lungs can no longer expand and contract, and we end up with very, very severe disease. So fat cells, whether it's fat cells themselves or the lipofibroblasts, are part of the disease process. Let me show you what it looks like. At the top of the fat cell that you see at the center is a Y-shaped ACE2 receptor. That's where the virus attaches. It then enters the cell, replicates, and causes severe disease. So it turns out, though, that it's not just obesity. When we look at diabetes, as soon as the pandemic emerged, it was clear that people who had diabetes were more likely to die of this disease. 2.7% for people without diabetes, 7.8% mortality for people with diabetes in Hubei province in China at the very beginning of the pandemic. But it was not just a question of whether you had diabetes, it was a question of what was happening with your diabetes. People with diabetes in poor control had an 11% mortality. People whose diabetes was brought under control had a 1% mortality. Well, how did they define these terms? Poor control was defined as an A1C of around 8.1% and good control 7.3%. Now you might be thinking, wait a minute. If my A1C is 8.1%, can I get it to 7.3%? Easily. You can do it with medication, of course, very rapidly, but you can do this convincingly and healthfully with diet and lifestyle changes. And all the side effects are good ones. So what is a healthful diet that might help us tackle diabetes? I'm going to tell you something that you already know, and that is that different groups following different diets have a very different disease prevalence. And some of the most influential data come from large cohort studies. The Adventist Health Study 2 enrolled almost 61,000 people. And the reason that Adventists have been put under the microscope is because you have a large group of non-smoking, mostly teetotaling, health-conscious people, but they differ in diet. And in 2009, the American Diabetes Association published these data. Looking at meat eaters, or what they called non-vegetarians, their body mass index was higher than it should be. As you know, BMI is your weight, but it's adjusted for how tall you are. And the BMI, body mass index, we like to see it below about 25. Some even would say below 23, but the non-vegetarians were way above 25. They're at 28.8. Semi-vegetarians, defined as people who eat meat but less than once per week, they were a little thinner at 27.3, and pesco-vegetarians, consuming fish but no other meat, were only a little slimmer at 26.3. Now, lacto-ovo-vegetarians, people who consume dairy products but also eggs, were a little bit better at 25.7. But look at that blue line on the right. Now, I have to tell you, a vegan is not a person from the planet Vegas. A vegan is a person who consumes no animal products at all, and they were actually the only group in the healthy body mass index range. But when we look at diabetes, we see not only the same gradient, but it's much more severe. Meat eaters have a lot of diabetes. Vegans have very, very little diabetes. And that shows that when people follow this kind of healthy diet over the long term, they tend to do very well. Well, the question, though, is, what if I have diabetes already? Is there something that I can do? Well, in 2003, the National Institutes of Health asked our research team to do a head-to-head test of a conventional diet versus a plant-based diet. Now, what we did is we brought in individuals who had type 2 diabetes. On average, they'd had it for about 8 years, and half of them began the conventional diet. And that means three things: limiting calories so that you're trying to lose weight, And I can imagine what you're thinking. You think, good heavens, if I have diabetes and my dietitian told me I had to cut a lot of calories off my diet every single day, it gets old by about Wednesday. But that's very common practice. The second step was to limit carbohydrate and keep it steady from day to day. And third was to limit bad fats, meaning saturated fat and trans fats. The plant-based diet was very different. It was no animal products, minimizing the use of oils. So we taught our participants ways of preparing food without adding oils, and favoring low glycemic index foods. And if that's in any way a new word, high glycemic index simply means that a food raises your blood sugar rather quickly, like white bread. White bread causes the blood sugar to rise rather rapidly. But beans or lentils have quite a very different effect. They have carbohydrate, but it's not absorbed into the bloodstream rapidly. So we call it low GI. So this is not a low carbohydrate diet at all. There's lots of healthy carbohydrate, but we choose the ones that are gentle on your blood sugar. So no animal products, minimize oils, favor the low glycemic index foods. And when we look at A1C, as you know, for a person with diabetes, we'd like to keep it below 7. Well, our participants started around 8, and on the conventional diet, the portion-controlled diet, they did well. That's the red line. They dropped by about 0.4, but the blue line shows people on the vegan diet, the plant-based diet. They dropped by about 1.2, maybe even a little bit more, which is huge. If you have an oral medication that can drop your A1C that much, that's a great medication, and it was called asparagus, or beans, or broccoli, or spinach. These are simple plant-based foods that have effectively a medicinal power. Okay, let me share with you the story of one of our very first research participants. His name was Vance. His father was dead by age 30, and he told me of family members who had lost legs or lost their vision to this disease. He was 31 when he was diagnosed with this disease, and he was in his late 30s when he came in to see us. But he began the vegan diet, and one of the first things he said was, "This is the easiest diet I've ever done." Now that was surprising, because many people imagine that a vegan diet is challenging. They imagine that it means changing and disrupting your lifestyle. He said, no, it's just the opposite. When I did an old-fashioned diabetes diet, they made me cut my calories, so I went to bed hungry every night. They made me count my carbohydrate grams at every meal. It was boring and tedious. But with a vegan diet, it just means instead of a meat stew, I have a lentil stew. Instead of a meat-based soup, I have a vegetable soup. Instead of meat on my spaghetti, I put a tomato sauce on my spaghetti noodles. It's easy. And as time went on, he lost about 60 pounds. His doctor stopped his diabetes medications, and his A1C fell from 9.5, which is poor control, to 5.3. And when we got his lab test, with an A1C of 5.3, which is not diabetic, nor is it in the pre-diabetes range, it's in the absolutely normal range, we started to recognize that this disease is not a one-way street. When I was in medical school, I was taught what you may have been taught, that once you have diabetes, you'll always have diabetes. Now, there's a reason why doctors have said that, is they want their patients to take this disease seriously. But here was a person who didn't always have diabetes. He had changed his diet and changed his lifestyle, and he could go into any clinic in the world, and they would never diagnose him as even having had this disease. So we now realized what is possible. Now, we then started working with a car insurance company here called Geico. It's one of our biggest insurance companies in America. And they have many people with diabetes on staff. And they asked if we would begin a program at work. And so we said, sure, let's do two things. Let's have vegan food in your cafeteria. So instead of bacon and eggs for breakfast, why not have oatmeal porridge? And they said, let's do that, and let's have classes for people. Now, there were a few missteps along the way. The cafeteria manager was not entirely sure what should go on a vegan burger and had to learn that, no, you don't put bacon and cheese on your vegan burger if you don't mind. Sorry. They had to correct that. But as time went on, people who followed this program lost a substantial amount of weight compared with controls who did not follow the program and they didn't lose weight. And then when we looked at hemoglobin A1C, exactly what you'd predict to happen happened, is that it got better. And for people who didn't follow the program, it did not. So that was very convincing. And people beginning the program were thrilled. Their lives were transformed. They were able to lose weight. They were able to improve their health. And they started to feel that there were things they could do that they couldn't do before. Hillary and Bruce were our youngest participants in the first Geico study. And Bruce sent me this picture because he said, the two people on the left were embarrassed to go to the gym. They didn't feel like exercising, and we didn't eat very well. But after we went on a completely plant-based diet, we lost weight, and we regained energy, and then we felt like exercising again. And they sent me this picture when they ran their first half marathon. The idea is that these mental constraints that we often have about who we are and what we can do can dissolve away when we're on a healthier diet that gives us more possibilities. So in 2014, this meta-analysis looked at all the studies done up until that point, looking at hemoglobin A1C in plant-based diets. If you're unfamiliar with a forest plot, it's this graph, and you see the third vertical line says 0. If you're to the left of that line, that means in this study, your hemoglobin A1C on average got better. And as you can see, that happened in every study. It's extremely consistent. When you put people on a plant-based diet, they tend to lose weight, their A1Cs come down. It's an extremely consistent effect, which is good. So a healthy diet, fruits, grains, vegetables, legumes, and don't forget your vitamin B12, which you need for healthy nerves and healthy blood. So let me walk you through how this works. Now, I know that many of the participants in this program have lots of expertise in how diet affects our health, and specifically on what happens at the cellular level. But for anybody who's in doubt, if you don't mind, indulge me in taking a minute and a half to describe what happens inside your cells, because I want to show you the cause of type 2 diabetes. And then I would ask you to share this with your physicians, because many of them forgot this part about medicine. What this big purple oval that you're seeing is a muscle cell. Muscles are powered by glucose. That glucose is in the blood, and it can't do any good for that muscle at all. That muscle will keep it out until you have a key that will let it come in. The muscle membrane keeps it out. But there is a key. That key is insulin. It's made in your pancreas, and the insulin goes from your pancreas through the blood to the surface of that muscle cell where it attaches to that receptor, just like a key in a lock. And when the insulin arrives at the surface of the cell, something wonderful happens. Just like a key can open a lock, that insulin key attaching to the receptor will open small channels on the surface of the cell that permit the glucose to come inside. And now the blood can free itself of all that excess sugar. It can go into the muscle cells where it belongs and can give you the energy that you need. Well, what could ever go wrong? Well, how could my insulin stop working? Well, in America, unfortunately, people have a dinner that looks like this, and they have a lunch that looks like that, and they have a breakfast that looks like that, and people eat all kinds of foods that are not so good for them. And these foods have fat in them, and that fat builds up inside the cell. And as animal fat or even vegetable oils will pack into the cell, the key no longer works. What do I do? Well, that fat is intramyocellular lipid. You remember that name. That's the fat that's inside the muscle cell, and the same thing happens in the liver cells, called hepatocellular lipid. If I go on a diet that has no animal products in it, how much animal fat is left? None. And if I keep oils low, the fat starts to dissipate. That's important because as long as the fat is there, the insulin key doesn't work. The cell membrane can't open up. The glucose bounces right off, nothing happens. But once I follow this healthy diet, little by little, the fat starts to disappear. And as that fat goes away, that key can work again. And as the insulin resistance melts away and insulin sensitivity returns, the glucose can come into the cell and everyone's happy again. Okay, good. So let me take you now to New Haven, Connecticut. Dr. Kit Peterson and Dr. Jerry Schulman brought in young people and they tested them to look at their insulin function. Now, what they did is they brought in 26 young, thin, non-diabetic volunteers. And they asked them to have a glucose tolerance test, and some of you have had this test, where you drink syrupy goo, about 75 grams, and the sugar goes into your blood, and if everything goes well, you'll be insulin sensitive, meaning that your body is able to take the sugar that you swallowed, it goes into the blood, but it quickly goes into your muscle cells, out of the blood into the muscles. That's insulin sensitivity. But on the other hand, some people are insulin resistant. So I drink that syrup, and now the glucose builds up in my blood, and it stays there because the insulin cannot get it into your muscle cells. And it stays in the blood, and your doctor says your blood sugar is high. Okay, so let's look at these individuals. They were young, 28 years old for the insulin-sensitive groups, 26 for the insulin-resistant group. They were thin, 60 kilograms for one group, 64. These are not overweight people. And they did not have diabetes, 5.1, 5.2 A1C. Okay, however, we are now going to go into the MR spectroscopy machine, magnetic resonance spectroscopy. This is a technique that allows us to look into your muscles in real time. And I want to show you the results. On the left-hand side of your screen, you see intramyocellular lipid. These are the control subjects, the healthy subjects. Every dot here is a person. Now, if you compare the healthy people, whom you see depicted here, to the insulin-resistant people, the difference is obvious. The insulin-resistant people have a dramatic increase in their intramyocellular lipid. That's why they have insulin resistance. But there's more going on. If you look at their mitochondria, do you remember this from your high school biology? Your mitochondria are the burners inside your cells. They are what give you energy. Every dot here is a person. And if you compare, by the way, if you're having trouble seeing the entire screen, you can minimize the little photo strip on the right, and then you can see everything. As you can see, the individuals on the right who are insulin resistant have not only more intramyocellular lipid, they have less mitochondrial activity, meaning the fat that's getting into their muscle cells, also into their liver cells, is interfering with their cellular metabolism. Something's going wrong because of the fat. Now, I want to tell you that just last week, my group did a study that was published in JAMA Network Open. And this was a study done by Hanna Kaliova on our staff and Kit Peterson and Jerry Schulman from Yale University. We worked together. We brought in 244 individuals. Half of them went on a healthy vegan diet. The other half went on a control diet. And then after 16 weeks, we did a variety of tests on them. And the first test is you just put everybody on the scale. And what we saw was that the people in the control group didn't really lose much weight. The people in the vegan group lost, on average, 14 pounds, which is about 6.4 kilograms over 16 weeks. Very impressive. We then asked, why are they losing weight? Well, the first reason is they're eating more fiber, more plant roughage, which effectively has no calories, but it fills you up. Also, their diet is switching from fatty foods like cheese and meat and fried foods. Fat has 9 calories per gram, shifting to carbohydrate, which has only 4 calories per gram. Now, some of our participants were afraid of carbohydrate. They were thinking, good heavens, if I eat lentils and rice, the carbohydrate in there will make me gain weight. We have to remind them, carbohydrate has only 4 calories per gram. When we shift from the fatty foods to the carbohydrate foods, weight loss occurs. Okay, so we then looked at insulin resistance. So as these individuals were following a vegan diet, not only did they lose weight, but something else was happening inside their cells. Their insulin resistance was melting away, but in the control group, they were not getting better. So then we did a test called indirect calorimetry, and this is Dr. Kaliova administering this test. What you do is you lie down on the table, and I put over your face a plastic bubble that allows us to measure your carbon dioxide intake. Carbon dioxide output and your oxygen intake. If you are metabolizing slowly, you don't put out very much carbon dioxide. If your metabolism is high because your mitochondria are working, you're putting out a lot more carbon dioxide and taking in more oxygen, and that shows us your metabolism. Okay, so what did we find? If you come into our laboratory at 6 o'clock in the morning as one of our research participants, you're wearing your pajamas, you haven't had breakfast, and you lie down on our exam table. At that point, we discover your metabolism is very slow because you haven't had breakfast. At that point, I will give you a meal. And then your metabolism will rise for about 3 hours. That always happens because you're ingesting food and you're absorbing the nutrients. But after you've been following a vegan diet that's low in fat, after 3 or 4 months, come back, lie down on the same table, and let me give you the same breakfast. What we discover is that your metabolism is not the same. You burn even more calories after the meal, roughly 14-15% more calories in the after meal period. What's going on? Well, we call it the thermic effect of food. If you're ingesting food, maybe it will go straight to body fat. Or maybe some of the calories in that food will go to give you energy and be given off as body heat and not going to fat at all. Well, in the control group of our individuals, again, we had 244 people, 122 of them were in the control group. This is their after meal calorie burn. The white line is before they started. We fed them the meal, their after meal burn rose as it always does. 16 weeks later, we did the same test, and nothing much happened. It was the exact same rise. They weren't burning calories any better after 16 weeks than they were at the beginning. Well, look at the vegan group. The white line, again, is at the beginning. They were burning calories faster after the meal, as always happens after any meal. After following a vegan diet for 16 weeks, though, you have that light green line. And as you can see, after 30 minutes, 60 minutes, 120 minutes, they start to burn calories faster after the meal. It's not a dramatic difference. It's just a little extra advantage where the vegans are burning calories a little bit faster after every single meal. So why do people following a vegan diet lose weight? Part of it is they're eating lots of fiber and lots of carbohydrate. That reduces their calorie intake. But the other part is because after each meal, they're burning calories more like they did when they were 15 years old. Okay, so this is the MR scanner. And with MR spectroscopy, we can now look into our muscle cells. So our participants here in Washington, D.C., went to New Haven. They went to Yale University, where Dr. Kit Peterson put them in the MR scanner. And what we found is that liver fat specifically dropped 34% in the vegan group, and it didn't improve in the control group. So what we're seeing is that when people do this kind of diet, yes, they lose weight, but their insulin resistance starts to go away. Their mitochondria are freed up again. Their liver fat starts to diminish. In other words, it's not just changing the number on your scale, it's changing your body in a dramatic way. So this study, published just last week, shows that after 16 weeks, you see weight loss, you see improved insulin sensitivity, better metabolism, and reduced liver fat, substantially so. Okay, so let me go into a little more detail. Please fasten your seatbelt. I would like to talk with you about how fat slows your metabolism. It's true, the fatty meals that people eat, whether they're in India or in New York or in London or in Paris, all kinds, wherever they may be, people are eating all kinds of fat. And this is our muscle cell, and those are our mitochondria, and they are trying to give us energy. But fatty meals cause the fat to build up inside the cell, and that interferes with the mitochondrial action. So fat in cells slows your after-meal calorie burn. Your mitochondria can't burn calories if fat is getting in the way. What do? Wherever I may live in the world, I can get the animal products off my plate. And if I do that, the animal fat is gone. And if I keep the oils really low, something happens in my cells, which is the fat starts to dissipate. And then I get my after-meal calorie burn back. Very, very simple. Okay? All right. At Pennington Biomedical Research Center, individuals put this to the test, not over 16 weeks, but over 3 days. They asked individuals to eat an especially fatty diet. 50% of their calories were from fat. And what you see on the left is mitochondrial biogenesis. What that simply means is that our bodies will change our mitochondria. The mitochondria in your cells, these burners, aren't static. They don't stay the same. You don't have the number when you're 60 that you had when you were 17. You make more, you make less, they coalesce. They change constantly depending on the energy needs of the body. What the figures show is that when you eat a fatty meal, the number of the mitochondrial biogenesis switches from what you see in the white bar to what you see in the black bar. Fatty foods impair mitochondrial action, but they do so not over a year or 2 years or 5 years. They will do this within 3 days' time. It happens very, very rapidly. And the reverse happens rapidly as well. When we get the fat out of our diet, the cells rebound. You don't have to wait for 12, 15 years to get healthy. You've seen this. Many of the people in this program have seen how rapidly the changes can occur for the better. Okay, one other thing. This happens within your intestinal tract. The picture you're seeing here is a diagram of within your intestinal tract, you have bacteria, as you know. You have friendly bacteria that are making healthful products, but you also have some not very friendly bacteria. And they produce toxins called endotoxins. And normally, those bacteria stay in your intestinal tract, and the endotoxins stay in your intestinal tract too, so they can be flushed down the toilet. However, in some cases, they can pass down into your bloodstream. As you can see in the bottom of this slide, the toxins produced by the bacteria can slip into your blood. So, what researchers at Virginia Tech did is they hypothesized that if I'm eating a high-fat diet, it might disrupt that intestinal barrier. And if it disrupts the intestinal barrier, then the endotoxins can get into your bloodstream. And that fat itself might even escort them into the bloodstream. So if a high-fat diet allows the toxins to get into the blood, that can disrupt my cells. Is this true? What they did is they used a 55% fat diet, that's a high-fat diet, for 5 days. Again, not a long study, very short study. And what they measured was how much endotoxin is in your blood. On the left-hand side, you see before the high-fat diet, a relatively low level of endotoxin. On the right-hand side, you see after the high-fat diet, the endotoxin levels double. Okay, so this seems to support the hypothesis that a fatty diet disrupts the intestinal protective barrier, allowing toxins to enter your bloodstream. Well, so what? The problem then is when we look at the ability of the cells to metabolize. Normally, when you have a meal, your mitochondria leap into action and they give you energy. That's what you're seeing in the left 2 bars. Before you are on a high-fat diet, if you give people a meal, you see a big jump in their metabolism. That's glucose oxidation. That's normal. That should always happen. You eat foods, you oxidize the glucose. You use the sugar that came in. But the right-hand side, these other 2 bars show that after I've given you a high-fat diet for 5 days, then I give you a meal challenge, and the increase in your cellular oxidation, the glucose oxidation, is very, very little. It's blunted because something about that fatty foods is disrupting the cell's ability to work. What is it? Well, we believe it's the endotoxins coming from the bacteria entering your cells and disrupting your mitochondrial activity. So we've now seen many, many reasons why a high-fat diet interferes. It makes your cells not work well. Okay, now you might be saying, wait, I know someone who's had diabetes, not just for a year or two, but for many years, and now has all kinds of symptoms, including neuropathy. Can anything help at that late stage? Well, we asked that question. We brought in 34 women and men. They all had type 2 diabetes. They had had it for many years. They had painful neuropathy. It's pins and needles or stabbing pain in your feet, sometimes in your fingers. A control group was given vitamin B12, and an experimental group was given the same B12 plus a vegan diet. Why did we use B12? Because you need B12 for healthy nerves and healthy blood. And so we wanted to make sure that everyone had that on board. But the experimental group also had the low-fat, healthy vegan diet. And it was what you already know about: no animal products, low oil, low glycemic index. And the first thing we asked is, how do you feel? And do you feel any better at all? And on average, the control group in orange said, well, they were about a 3. I guess maybe I'm a little better. I don't know. The green line was the people on the vegan diet. And they said, yes, I'm between somewhat better and moderately better. All right. That was how they felt subjectively. We then did an objective test, which we do through galvanic skin response. You can put your hands on a metal plate where you're looking at the nerve's ability to produce perspiration. And you also do it in the feet. And it gives you an objective measure as are the nerves recovering. And what we found is that in the control group, they really weren't. That's orange. In the vegan group, by 20 weeks, the nerves were starting to recover their function. Now, 20 weeks is not a long period of time, but what we saw in that period of time in late-stage diabetes, the nerves were starting to repair, starting to get healthy again, so that we saw subjective and objective signs of improvement. All right. One last thing I just want to mention. Despite your best efforts to follow a very healthy diet, there are people who are manufacturing products that maybe don't have your best interests at heart. And you'll find that these are in front of you just about everywhere you go these days. And some people are particularly vulnerable to these. And let me share with you something. These are 2 brain cells. On the left-hand side, you see what I'm going to call the presynaptic neuron. This is a brain cell that is loaded up with little round vesicles containing little black dots. Those black dots are dopamine. Dopamine is a pleasure chemical, the reward chemical. When you do something that should give you a reward, the dopamine goes from the left-hand cell across that cleft to the right-hand cell. Nature programmed this for if we find a good food source or a receptive mate, you get a little bit of dopamine. Now, I didn't devise this system. This is what nature had in mind for us, but that's the way it works. Now, let's say you have a lot of receptors on the right-hand cell. See all those receptors? They're like docks, welcoming boats that have come across this river. If you have a lot of receptors, the dopamine can attach. It gives you a sense of pleasure, and you feel good. In fact, you feel pretty good all day long because your dopamine system is functioning. Some people are born with a genetic trait. Look at those receptors on the right. Now look at that. Some people are born with fewer dopamine receptors. So the dopamine still goes across the cleft, but it doesn't last long. And if it doesn't find a receptor before it dissipates, you don't feel very good. This trait is called the DRD2 TAC1 allele. That stands for dopamine receptor D2 TAC1 allele. It's totally genetic. You can get it from your mother or your father or both. And if you have this gene, then you just don't feel as good as other people do. But what you discover is that if you smoke a cigarette, you feel a little bit better because the nicotine causes dopamine to be produced. And so you get a little extra burst of it. Or you take a drink of alcohol, or some caffeine, or some cocaine, or some heroin, or compulsive eating, or compulsive gambling. All of these things cause extra dopamine to flood across that cleft. The point is that if you have this gene, you are especially vulnerable to all of these things and all the destruction that they can cause, including overeating. Is this common? In the general population, perhaps 1 in every 8 or 10 people has this gene. However, in one of our diabetes research studies, we took blood samples from everyone. And we found that in people with type 2 diabetes, 1 in every 2 has this gene. What does this mean? What it means is that you might have had a family history of diabetes. Maybe you're vulnerable to getting it. But if you also have a gene that makes you vulnerable to anything that will give you extra dopamine, including eating a sugary donut and having extra chocolate and overeating, then those temptations may be harder to resist. Now, you're probably saying, where do I get tested? Let me encourage you not to think so much about that, because actually every one of us is vulnerable to temptations. And there are food scientists who are working very hard day after day to find the exact mix of sugar and cocoa butter to put into a chocolate bar to seduce everyone. So whomever you may be, there are people who are going to try to get you hooked, and I hate to say it, some foods act like drugs, and they act that way for everybody. So if you have found that you were attracted to something, and maybe even you had a slip, and you ate something you wish you didn't, forgive yourself. This is biology. This happens. Dust yourself off and get back on the wagon. But on the other hand, this also means that we do better not tempting ourselves. You'll know people who say, okay, yeah, I like it. This healthy diet sounds pretty good. Maybe I'll do it most of the time, but now that the program's done, maybe I'll just kind of go back to, I'll include some of the other foods I missed. That is a very precarious thought, because very soon your dopamine system will take over your judgment and you're going to be right back where you started. Now, I'm a child of the 1960s, and we never liked rules. But I have to say, I've come to discover that there are some foods that I may love that just don't love me back. And if I set up a rule saying, you're not in my life anymore, I find I do a little bit better. So there are certain times of special vulnerability when we are hungry, when we're angry, when we're lonely, when we're tired. Halt. That's a useful thing that we learned from our other colleagues who are treating not just diabetes, but alcoholism or drug addiction or smoking or whatever. Look at the times of vulnerability and be aware of it. So when unhealthy foods are calling your name, at these times you'll see it. Okay, a healthy diet, fruits, grains, legumes, vegetables, and very quickly, you know that you need B12. It's not optional. You really do need it for healthy nerves and healthy blood. And the amount you need is very, very small, but you don't want to miss it. Now, if someone is watching this program because you were dragged in by a friend who said, you really need to pay attention to this, and you're thinking, well, I'd love to be healthy. It sounds great, but I'm sure it's completely impossible. Let me share with you how we do this in our clinic. I have never seen anyone unable to do this. Step one is you just take a week and check out the possibilities of healthful foods. Take a piece of paper, and for 7 days, write down food ideas of things that don't have any animal products in them. You might need some suggestions, but you'll think of them. A breakfast that is entirely plant-based, a lunch, a dinner. And after a week or so, you'll have a list. Very good. Now, step two is to take your list and for 3 weeks, eat those foods. For 3 weeks, no animal products, and keep oils very, very low. After 3 weeks, and by the way, you'll see that's very easy because, frankly, you could do anything for just 3 weeks, and you've already made your list, so it's easy to do. At the end of that time, 2 things will have happened. Physically, you'll feel better. Your blood sugar is better. You're losing weight. Your digestion is better. Your mood is better. But the second thing is that your attitudes about foods are changing. You're discovering you didn't really miss the foods you thought you couldn't live without. And you're discovering new foods. And you're discovering new products and new books and new ideas. In fact, you're discovering you have friends who've been doing this for a long time, wondering where you've been. So it's a wonderful voyage of discovery. You want to make sure you get there. Before I...